Hi everyone, in this episode of Keipert Labs we're going to discuss the Bohr model of the atom. So we're going to go through some of the features of this model, and then we're going to try and illustrate kind of how it looks for different types of atoms as a way to try and help us visualize why some atoms form ions. In order to help me, I'm going to use some of these colored kind of buttons to help visualize some things. So I hope you find that helpful. A little bit of extra production values, you might say. All right. So let's kind of take it back to the idea of this guy named Ernest Rutherford. Okay, proposed in around about 1911. Okay, so he proposed that we had a positively charged nucleus around which we got these kind of electrons orbiting around like this. So we could kind of, if these black dots are electrons, so they're orbiting around the nucleus. This kind of classic kind of, Simpsons kind of nuclear power plant kind of logo sort of look. Okay, so we had so we've got the nucleus in the middle, which has made up of protons plus neutrons, and then we've got electrons orbiting around the outside, which are negatively charged. Okay, so that was kind of the concept that he was working from. Or that he proposed to account for what he saw when he did his gold foil experiment, you might remember. And then what happened a very short time later, we got to this Danish physicist named Niels Bohr. Okay, and so he proposed that we still had a positively charged nucleus in the center, that was still made up of protons and neutrons, but that rather than being this kind of this sort of higgledy-piggledy arrangement of electrons, that actually it was much more ordered than that. Okay, so he proposed that electrons didn't orbit in just some kind of random sort of space, or some sort of all at the same kind of place, but they orbited in these things called energy shells, or electron shells. Okay, so energy shells or electron shells. Okay, so he proposed that a couple of things about that we can identify. That they went from low energy up to high energy. Okay, so that they weren't. You started off with some energy shells that were lower in energy, and then progressively made your way up higher and higher and higher to very high energy shells. Okay, and so the other thing that he proposed was that these electron shells had a fixed capacity. So that is a specific number of electrons. Only a specific number of electrons could fit in a shell at any given time. Okay, and that he also said that can jump or transition between shells. Okay, this idea that electrons didn't have to stay in their shell if the conditions were right, that they could move from one shell to another. Okay, so if we kind of, if we said, all right, so we had some electrons in this shell, that then this electron up here could be made to jump up to the next one by absorbing energy. Okay, so it could go energy, and then it could drop back down again by emitting energy. And so, which is what helped to explain why we get different colors of light sometimes when we excite atoms of a particular type, like neon for neon lights and so on. Okay, so this was some of the ideas that he proposed. Okay, and so then let's kind of explore this a little bit further. Especially we're going to explore this idea of fixed capacity, because we're going to need to get a good understanding of that before we can move on. So, so this idea that shells have a fixed capacity. Okay, so what he articulated was that there was a mathematical kind of process or a rule for this. That shells could only fit a certain number of electrons, that for the first shell, and shell number 1, that you could fit 2 electrons. That for the second shell, that you could fit 8 electrons. And for the third shell, you could fit 18 electrons, and so on. That is, that the number that you could fit was 2n squared, 2 times the square of the number of the shell you were talking about. Okay, so then for n equals 4, okay, so 4 squared is 16, 2 times that is 32 electrons. And so what that means is that you have a certain capacity you can only fit a certain number of electrons in those shells. Before then, you need to go to the next energy shell in order to fill that up. Okay, so I'm gonna see if I can visualize this a little bit for you using my little colored buttons. So I'm going to draw. We'll have our nucleus over here, and then I'm going to try and draw. I'll take this out of the way. Some nice, neat circles, or semi kind of close as I can get. Okay, so it's to represent some of the elements that we're talking about here. Okay, so we can use our periodic table to help guide us this. So having it there might be a useful resource. Okay, so let's going to start with hydrogen. Okay, so we've got has an atomic number of 1, so we have 1 electron there. Okay, so easy fit. Okay, we then move to helium, and we have 2 electrons. So I take 1 and I add 1 more. But I've already told you that for n equals 1, we can get 2. N equals 2, we can get 8. N equals 3, we can get 18, and so on. Okay, so for my first shell, my first ring, I have a capacity of 2. That means that that shell is full. So I can't then decide to whack in a third one like that if I want to. It doesn't work that way. So now if I go to lithium, atomic number 3, 3 electrons. Okay, so I had hydrogen, I had 1. I had helium, I had 2. And now I've got lithium, so I've got 3. I've got a full shell of 2 here. So if I want to add a third electron, what I have to do is I have to start filling up the next shell. So I say I've got 2, and then I've got 1. If I want to go to beryllium, which is the next one, I've got 4 electrons, and so on. And so then I'm adding another electron. Okay, so I've got 2 and then 2. Boron, and so on, and so on, and so on. I keep on going up. Okay, so and let's start to look at, okay, let's skip a couple. I've got carbon. I've got 6 electrons. 1, 2, 3, 4, 5, 6. Okay, so carbon. So I'll just put a dot, dot, dot there. So carbon, I've got 2, and then I've got 4. I'm going to start putting commas in here so you can kind of keep track of where those numerals are going. Okay, let's do another skip a few. Let's go to oxygen, which has 8, 2, and then 6. So I've got 2, 1, 2, 3, 4, and then I'm going to go 5 and 6. Now one thing that I'm doing here, you can see, is that I'm actually, once I've gone beyond 4, I'm starting to pair them up. Okay, rather than spread them out evenly like slices of pizza. Okay, there's a good chemistry reason for that. Okay, but I won't go into it right now, but it's just this, it's something to get used to. Okay, and so then I skip another few, and so then I'm going to get to neon. Okay, neon has atomic number 10, so it has 10 electrons. Okay, I've got 2, and then I've got 2, 4, 5, 6, 7, 8. Okay, so what we get to, I have 2 and then 8. Now if I have a look at my list here, I can recognize that my second shell can only fit 8. Okay, so then if I say go to sodium, which has 11 electrons, all of a sudden I run into some trouble. Okay, I have filled this atom. I cannot fill it any further. What I have to do is I now have to add in an extra shell, and then I add my next electron there. And so I end up with 2, 8, 1. Okay? So what we see there is that now I've used my fixed capacity of my electrons to start filling up shells in my around my atoms in accordance with these rules. Okay? Now, I'm just going to in the next video, I'm going to talk through some of the patterns of what we see when we start to look at the arrangements of these atoms in the periodic table. Okay, but for now, we'll wrap this up. Thanks very much for watching. Bye for now.